Okay, I am going to attempt to teach or illustrate how to do integration by substitution. Um, these are the big three anti-differentiation rules that we're going to be using. What you do is if you're trying to integrate a function like this, you try to find an expression replaceable by u so that you can apply one of these rules. Okay? Best places to look: parentheses, in parentheses, under radicals, denominators, or in exponents. You take take u's derivative and it's called du. Add dx or dt or whatever. In this case, it'd be dx. Okay? After its derivative. Then you account for everything outside the u substitution as a multiple or fraction of du. And then you integrate with respect to u, and then you back substitute. So here we go. I'm looking for the integral of 66x squared times 2x cubed plus 7 to the 14th dx. Okay? So do. I will let u equal 2x cubed plus 7, because that's what's in parentheses, and I want to be able to apply that rule. Okay? Now du would have to be, the derivative of this is going to be 6x squared, and since it's dx, since it's with respect to x, we'll do dx. Okay? Now, the problem is so here's what I would have. I would have u to the 14th and 66x squared dx. Okay, is what I have. Okay? Here's u to the 14th, and here's the rest of it. Okay? So I'm going to put half. So let me illustrate what this is. This is going to be half, and this is out of du. Okay? I have 66x squared dx. du is 6x squared dx. All right? So 66 divided by 6 is 11, and I'll tack on a du. Okay? So what I have is I have the integral of u to the 14th times 11 du. That accounts for all of this. This is the u to the 14th. This is 11 du. Okay? So, I'm going to rewrite this in a more standard form. The integral of 11 u to the 14th du. And I'll follow that rule right there. So that's going to be 11 times u to the 15th over 15, and then plus c. Okay? Which gives me 11 u to the 15th over 15 plus c. And now that the integration is over, I need to back substitute. So I have 11 times 2x cubed plus 7 to the 15th over 15, and then plus c. All right? I'm going to pause here and set up another example. All right. Now, next step, I have the integral of 12x to the 5th times 5x to the 6th minus 17 to the 21st power dx. So here goes. Do. U will equal 5x to the 6th minus 17. It's in parentheses. Du would equal 30 x to the 5th, and then since it's dx, since it's with respect to x, we'll do dx. Okay? So, underneath the radical, or within the integral, I have u to the 21st, and I have 12x to the 5th and dx. So that's u to the 21st and 12x to the 5th dx. All right? Half over du, that's going to be 12x to the fifth is what I have. Du is 30x, oh, forgot my dx. Du is 30 x to the fifth dx. So that's du, and that's what I have. Well, that reduces to 2/5. So 2/5 du. Do that again. Half over du equals 12x to the fifth dx. So that's what I have. Du is 30x to the fifth dx. And that reduces to 2/5. And I'm going to stick a du after that. Okay, so what I now have is I have the integral of u to the 21st and 2/5 du. Okay? Now, I'm going to rewrite this in a more standard order. 2/5 times u to the 21st du. And then I'll follow the reverse power rule here. Okay, so that's going to be 2/5, and then I'm going to have u to the 22nd over 22 plus c. And these reduce 1 and 11, and I'll go ahead and back substitute. That's going to be, well, I won't do that just yet. U to the 22nd over 55 plus c. Okay, and then that's going to be, since u was 5x to the 6 minus 17, it's going to be 5x to the minus 17 over 22. 5x to the 6 minus 17 to the 22nd over 55, and then plus c. I'm going to pause again and set up another example. Okay, I kept the previous example 2, and now I'm going to switch over to example 3 over here. Okay, now I have the integral of 3x over the fifth root of 19 minus 30x squared. Okay, this could be rewritten as the integral of 3x times 19 minus 30x squared to the negative 1/5 power dx. Okay, because it's a radical, it's going to be the 1/5 power, but it's in the denominator, so that's going to be negative 1/5. Okay, so u will equal 19 minus 30x squared. Du will equal negative 60x dx. Okay, so here's what I would have. I would have u to the negative 1/5 and 3x dx. Okay, so that's negative u to the negative 1/5 and then 3x dx. So have over du, I have 3x dx. Du is actually negative 60x dx. Well, 3 over negative 60 reduces to negative 1/20. So I'll have negative 1/20 du. Okay? So I have the integral of u to the negative 1/5 times negative 1/20 du, which I will rewrite in a more standard form as the integral of negative 1/20 u to the negative 1/5 du. And once again, it's the power rule. Okay? So this is going to be negative 1/20 times u to the negative 1/5 plus 1 over, let me try to make this more clearly an exponent. negative 1/5 plus 1 over negative 1/5 plus 1, and then plus c. Okay? So this is going to be negative 1/20 u to the 4/5 over 4/5 plus c. All right. So this will be negative 1/20 divided by, let's see, negative 1/20 divided by 4/5 is negative 1/20 times 5/4. I'm working this out. So 1/4, negative 1/16. So I'm going to have negative 1/16 u to the 4/5 plus c, which I'm simply going to rewrite as negative 1/16 times 19 minus 30x squared to the 4/5 plus c. And then I'm going to pause and set up another example. Okay, so next up, I have negative 8x to the 7th times e to the x, and the e power of e is x to the 8th plus 15. These are both part of an exponent. So I'm looking at using this rule, okay, because a good place to look is the exponents. So u will equal x to the 8th plus 15, the power of e. Du is 8x to the 7th dx. That's the derivative of x to the 8th is 8x to the 7th, and then it's going to be dx. Okay? So what I have is e to the u and negative 8x to the 7th dx. That's e to the u, because that's u, and that's everything else. Okay? All right. So have over du, I have negative 8x to the 7th dx. The actual du is 8x to the 7th dx. And this simply reduces to negative 1 du. So I have negative du. So it's e to the u, the integral of e to the u, times negative 1 du. I'm going to write that in a more standard form. The integral of negative 1 times e is negative e to the u, and then I have du. Okay? Well, the antiderivative of e to the u is e to the u. So I will simply have negative e to the u, because the antiderivative of e to the u is itself, and then plus c. And that's going to give me negative e to the x to the 8th plus 5th power plus c. All right? And now I'm going to pause and set up another example. Okay, now I have the integral of the square root of 16t plus 3 dt. Okay? So what I'm going to do is I'm going to rewrite this as the integral of 16t plus 3 to the 1/2 power dt. Okay? Now, u will therefore equal 16t plus 3. Okay? Du is the derivative of this is just, the derivative of this is just 16. And that's with respect to t, so dt. Okay? The derivative of 16t is 16, the derivative of 3 is 0. So that's what we would have. Now, I have u to the 1/2 power and dt. And that's all I have. I have u to the 1/2 power, because that's u, So u to the 1/2 power in dt. That's all I have. Okay? So I'll do my have over du trick. Have is 1 dt. Du itself is 1/16. I'm sorry, du is 16 dt. So this gives me 1/16 du. Okay? dt is 1 dt. I put over 16 dt, which is the actual du, gives me 1/16. Okay? So, my integral is going to be u to the 1/2 power times 1/16 du. I'm going to put that in a more standard format as the integral of 1/16 u to the 1/2 power du. Okay, and then that's going to be right for the power rule. So that's going to be 1/16 times u to the 3/2 plus, I'm sorry, just 3/2. Oh, let's just do 1/2 plus 1. Over 1/2 plus 1, and then plus c. Okay? So that gives me 1/16 u to the 3/2 over 3/2 plus c. All right, and I'm going to do 1/16 divided by 3/2. All right? So that gives me 1/16 times 2/3, 1/8, 1/24. So what we will have is 1/24 u to 3/2 plus c, which I'm going to go ahead and convert as 1/24 times 16t plus 3 to 3/2 and then plus c. All right. So you guys can compare example 4 and example 5, and then I'm going to pause the video again and set up another example. All right. I have 72x to the 8th times 8x to the 9th minus 125 all to the 15th power. In parentheses, I have u being equal to 8x to the 9th minus 125. Okay? So du will equal 72x to the 8th, and then it's going to be with respect to x, so dx. Okay? Now, here's what I have. I have u to the 15th, and so I have u to the 15th, and I have 72x to the 8th. (72x to the 8th) dx. So u to the 15th and 72x to the 8th dx. Okay? So now I'm going to do my half over du. I have 72x to the 8th dx. And I have as du is 72x to the 8th. And then the dx. Okay? And guess what, folks? This is du on the nose. I had du exactly. Okay? I had du exactly. So all I need to do now is u to the 15th and du. You'll have that happen sometimes. So this is going to give me u to the 16 over 16 power plus c, which will back substitute as 82, or 8x to the 9th minus 125 to the 16th power over 16 and then plus c. Sometimes it will be that easy, folks, okay? Remember that sometimes it can happen that you'll have your u, you'll take your du, and that du will match everything that's outside the u substitution. It does happen. And when that happens, these become super, super easy. So not all of these are supposed to be hard. Again, I'm going to pause here and set up another example. All right. Example 7 is 10x to the 4th minus 3 over 2x to the 5th minus 3x plus 12 to the 7th dx. So this can be rewritten as the integral of 10x to the 4th minus 3 times all this to the negative 7th power. Okay? This times the denominator is a negative exponent. Okay? So the best place to look for u, all things being equal, is the denominator. Okay? So I'm going to use u equals 2x to the 5th minus 3x plus 12. The reason I chose this is because it was a denominator and it's in parentheses. Okay? So du is a derivative of this. So this is going to be 10 x to the 4th minus 3. Okay? I'm sorry, I need to rewrite this. Du, I just wrote d. Du will be 10 x to the 4th minus 3, and that's going to be dx again. Okay? Now, so here's what I have. I have u to the negative 7th and 10x to the 4th minus 3 dx. Okay? Or 10x to the 4th minus 3 dx, since the parentheses aren't really necessary in the context of this lingo. Okay? So here's what I can, so I'm going to do half over du. So that's going to be, I have 10x to the 4th minus 3 dx, and du is actually 10x to the 4th minus 3 dx. And once again, like with the previous example, I have exactly du. So outside the u substitution, I had something that exactly matches du. Okay? Again, that can happen, and it happened again. Okay? So what I have, I have du exactly. Okay? So I'm going to have the integral of u to the negative 7th du. Okay? And that's going to be u to the negative 6 over negative 6 plus c. Because remember, you're going up a power. And going up a power from negative 7 would be negative 6. So this is going to be negative 1/6 u to the negative 6. Actually, what I'm going to do is I'm going to go ahead and put u to the negative 6 down here as a positive 6. So that's going to be negative 1/6, and u to the negative 6 will go to the bottom as a positive exponent, and then plus c. Giving me negative 1/6, and then u was 2x to the 5th minus 3x plus 12. This is going to be the 6th power, and then plus c. I'm going to pause here and set up another example. Okay. Now what I have here is I have 32x cubed minus or plus 160x over x to the 4th plus 10x squared minus 18 all dx. Now here's something to notice. This is something over a denominator to a power other than 1. In which case you'd want to use this strategy. But if you have something over a denominator to no power, you're going to want to follow this rule. Okay? So, remember, the best place to look for u's are parentheses, radicals, denominators, or exponents. So u will equal x to the 4th plus 10x squared minus 18. Okay? And du is 4x cubed plus 20x dx. Okay? Now, what I have is I have 1 over u, because that's not u to a power. That's not u to a non-1 power. Okay? Here, you'd want to use this strategy, but because that's a power other than 1. But in this case, folks, you're going to need to follow this rule. Okay? So I have 1 over u and 32x cubed plus 160x dx. Okay? So I'm going to do my half over du trick. So I'm going to take this, that's going to be 32x cubed plus 160x dx over, that's what I have, and actual du is 4x cubed plus 20x dx. Now folks, if you have multiple terms, it's best to factor out anything that you can. So that's going to be, these two are both divisible by 16x. So that's going to be 2x plus 5. And then don't forget the dx. And then these two are divisible by 4x. Actually, I didn't go high enough. Let me try this again. These two are both divisible by 32x. And that gives me x plus 5. And then I have dx. And then down here, these two are both divisible by 4x. I have x plus 5 again, dx. All right, so 32 divided by 4 is 8. So I have 8 du. That's what I'm going to go with, because 32 divided by 4 simplifies as 8. So my integral is 1 over u and then 8 du, which I'm going to rewrite in a more standard form as the integral of 8 times 1 over u du. Try to write that more neatly. The integral of 8 times 1 over u. Dang on it. I'm sorry I'm having so much trouble writing legibly. So 8 times 1 over u and then the du. Okay. Now, that's going to be 8. The antiderivative of 1 over u is the natural log of the absolute value of u. And now I will back substitute. 8 times the natural log of u, x to the 4th plus 10x squared. I'm going to need to write this more compactly. 8 times the natural log of x to the 4th plus 10x squared minus 18, absolute value braces, plus the c. Okay? I'm going to pause here and set up another example. So I have the integral of e to the 17 minus 14th power dt. So again, the best places to look for a u substitution, are in parentheses, radicals, denominators, or exponents. Okay? So u will equal 17 minus 14t. Okay? du, the derivative of this is 0, and the derivative of negative 14t is just negative 14. So I have negative 14 and then dt. Okay? So what I have under here is I have e to the u, and so e to the u and dt. That's what I have. Okay? I've got e to the u and dt. So have over du, that's good. I have 1 dt. I have the actual du is negative 14 dt. So this would become negative 1/14 du. Okay, so that's the rule I'm going to follow. The integral of e to the u times negative 1/14 du. I'm going to rewrite that in more standard form as the integral of negative 1/14 e to the u times du. Okay? The antiderivative of e to the u would be e to the u. So I simply have negative 1/14 e to the u, and then I'm going to need my plus c again. And now I'm going to back substitute. Negative 1/14 e to the u was 17 minus 14t, and then plus c. All right. I'm going to pause here and set up another example. Okay, example 10 is going to be a definite integral. The integral is x goes from 0 to 1 of 54 times 1 minus 9x to the 50x. So what I would worry about is I would let u equal 1 minus 9x. du is therefore going to be the derivative of this. So that's 0 minus 9. The derivative of negative 9x would be negative 9. And I'm going to need dx here. But what I have is I have u to the 5th and 54 dx. Okay? So half over du would give me, I have 54 dx. Actual du is negative 9 dx, which gives me negative 6 du. Okay? So what we're looking at is the integral as x goes from x equals 0 to x equals 1. I don't know if that's technically the mathematically correct way to write this, but I'm going to write it that way anyway. So it's going to be u to the 5th times negative 6 du, which becomes the integral as x goes from 0 to x equals 1 of negative 6 u to the 5th du. Okay? Which gives me negative 6 u to the 6th over 6 as x goes from 0 to x equals 1. And that cancels, giving me negative u to the 6th as x goes from 0 to x equals 1. Okay? So that's going to be negative 1 minus 9x to the 6th as x goes from 0 to 1. So at x equals 1, I have negative 1 minus 9 times 1 to the 6th, which gives me negative 1 minus 9 is negative 8 to the 6th power. I'm going to need a calculator for that. So that's going to be negative 262, 144. At x equals 0, I'm going to have negative 1 minus 9 times 0, all the 6th power. 1 take away 0 is just 1. So that's going to be negative 262, 144 minus negative 1, which equals negative 262,143. And that is your final answer.